Marina, and thank you for the invitation to visit with folks during this webinar today. So as a state climatologist of South Dakota, I kind of cover everything from flood to drought and everything in between. And just to start off, here's a picture of our yard outside of Aberdeen, South Dakota, which is in the northeastern part of the state. This is from last summer, and the only thing green you can see there are the kochia weeds coming up in the yard. So last year was certainly a severe drought year, but we've had tremendous recovery in part of the state, but that doesn't mean we're out of the woods yet. And so we continue to monitor drought conditions really all year round around South Dakota. And it sounds kind of funny to think, you know, when you're in a northern climate where you have winter and you think drought might not matter, but it really does still, even in our economy and our landscape that is so agriculture driven, even wintertime drought can make a difference. So let's go to the next slide. And I'll kind of step through a handful of things that we do, or I do, as far as monitoring drought conditions in South Dakota. One of the first things, one of the primary things that I do is work with the U.S. Drought Monitor, of course, on a weekly basis. You know, obviously more, we stay on top of that more when we are in drier drought conditions, but we do watch that all year round. And I have a group of people that I collaborate with on a weekly basis to kind of come up with a consensus recommendation for South Dakota. Again, as Richard said, they're looking at a lot of different indicators and across a lot of climate zones on all the seasons, and it can be a very difficult task for the drought monitor author. So we try to make that a little easier, coordinating with the National Weather Service offices. We have 3 that cover South Dakota. We also have a state geologist, a state fire meteorologist, and then also our state water rights staff in our Department of Ag and Natural Resources. So I work with all of them and others around the state to kind of keep tabs on things week to week. The next advance here, Adam. Yep. So one other thing too about monitoring drought conditions is that we actually have what we call an incident annex in South Dakota, in which myself and the state fire meteorologist help inform the governor's office every spring about drought conditions. And we've already started having those communications with the Drought Task Force in South Dakota, given our current drought situation. And on or around May 1st, the governor's office usually makes a statement if they need to activate that drought task force for the season or the year and that kind of thing. But certainly they watch the drought monitor as well. All right, next advance. I work with within South Dakota State University Extension. And I work with a lot of areas of extension, but primarily the agriculture side. So that includes crops and livestock and natural resource management. And we communicate all year round. Each one of those groups has a different schedule. Some go weekly, some go monthly, and might depend by the season. But they also do their own programming as far as drought conditions go. And so they're keeping an eye on things. And they're also a lot of my eyes and ears out around the state as far as what impacts are going on and helping verify what we see in the climate data. Next is that communication can happen quickly in a small state. You know, we have just under 900,000 people in our whole state. So fortunately or unfortunately, you know, everyone is a neighbor, and but we can fortunately get word out when there are drought conditions in place. And then the last one is that we also collaborate with the U.S. Department of Ag and their offices in the state, whether it be Natural Resource Conservation Service, Farm Service Agency, and also regional efforts like the climate hubs. So a lot of it is communication when we're talking about monitoring drought in a state like ours. And so going specifically to the soil moisture part of this, which really is an area of increasing importance, I'd say, because now we're starting to know more. We have more measurements, more ways of looking at it. And you think of South Dakota generally as this flat, maybe flyover state. And really our soils are pretty diverse. We're the eastern side of the state with glaciated The western side was not. So we have very different soils west of the Missouri River as we do east of the Missouri River, which you see kind of bisects right through the middle of the state, that black curvy line. So we see some differences in soil moisture and soil response to precipitation in the eastern and western landscapes with the different soil types. All right, next slide. And I think we've seen versions of this before, but you know, unlike Richard, we don't put all the information into our ArcGIS system. We look at a lot of these indicators and a lot of these different data sources to kind of get a handle on soil moisture. And this is one of our newer favorites, I would say, as far as soil moisture modeled or remotely sensed kind of data, where we're seeing a lot of different levels of a lot of different layers of soil, as Richard indicated, and a lot of different intervals and different ways of looking at soil moisture. So that's been really helpful. Also, the view, looking at the Dakotas, honing in a little bit more closely to home here is really helpful as well. So to folks who are putting this out, I really appreciate that, and the daily updates too, because you know some of the data does lag a little bit behind you know, this weekly monitoring that we try to do. All right, next slide. This isn't necessarily soil related specifically, but it's something we look at a lot when we're looking at rapid changes in drought. This is EDI, the Evaporative Demand Drought Index. And it does pertain to soil moisture a little bit. We're looking at evaporative demand of the landscape and plants, and how fast are we losing water. We tie this in with the soil moisture information that we see, and try to kind of ballpark your kind of make an educated guess about what is our loss of moisture on the landscape. How fast are we losing it? Are we seeing rapidly intensifying drought, for example, that could be drawing from our soil moisture reserves a little faster than we would expect at any time of year, or slower, you know, the converse side. So this is just one example, thanks to Mike Hobbins with EDI, who has been gracious enough to provide maps specifically for South Dakota. So we have a great way to look at products like these for our state level drought monitoring. You know, one thing, you know, thinking of the vegetation side and evaporative demand side, you know, the vegetative index and you know, some of those satellite drive greenness things are nice to have, but we have seen kind of false green signals, false or maybe maps that show after a rain event, you know, a quick rapid green up that maybe isn't really, you know, as much recovery as we might think. Might be more weeds or more of the undesired plants, not necessarily say a corn crop that we're really keeping an eye on. So this helps us understand a little bit better what's going on around the state. All right, next slide. So what we have as an advantage at the state level is digging into the data, you know, that people like Richard and Brad maybe don't have time to do. And so we're fortunate, or I'm fortunate, in that I can help contribute to those discussions on the drought monitoring side using our local data. And so Richard mentioned Mesonets, and we have our own Mesonet, our network of weather stations here in South Dakota that's operated by South Dakota State University. And the website is there, so I encourage you to visit that. We have a network of just over 40 stations right now. This is the current map of our active stations. And they're in a big time of growth right now, where they're growing to be over 150 stations statewide, covering almost the whole state here in about 5 years' time. So in pretty short order, we're going to know a whole lot more about soil moisture, temperature, you know, meteorological variables above ground and below ground at about a 25-mile scale, about 25 miles anyone will be within 25 miles, sorry, of a weather station, of a Mesonet station by the time they're done. So I'll show you a couple examples of some of the data products that we've developed in coordination with the Mesonet in a little bit. But let's go to the next slide first, just to give an idea of all the measurements that they take here. So it's 5-minute data posted live online. We've got most of the standard meteorological variables, with wind speed and direction, air temperature, pressure. Precipitation now, it's an all-weather precipitation gauge, so it measures rain, but also melts snow in the winter season. So this winter was really dry, so we didn't get to really test it too hard, but certainly it's exciting equipment to have. Snow depth is another one that helps contribute to our understanding of the water balance out around the state. Solar radiation, soil temperature and moisture, we have that at 5 different depths, which is really becoming really important. We also have things like inversion monitoring for temperature inversions, more for agricultural applications, and webcams. So you see a picture there on the right of one of the new configurations of one of the newer stations they put in last year. So with this information, we can measure essentially the whole water balance. And this is one example here using soil moisture. This is one of my favorite products. We call it the poker chip map. We have a stack of chips at each one of the locations, reflecting each one of the sensors at different depths. And the sensors aren't actually evenly distributed through the profile, but this is how the display works on the map, so it's a little easier to show there. White stacks show there's no data available. Unfortunately, it is only showing volumetric soil moisture. That's what we have at this time. And this is a snapshot from last fall, before we had freeze up of our soil. So in cold climates like ours, we see very little change typically in soil moisture over the winter season when the soils are frozen. So this often gives us a good picture of our starting point in the spring when we're in the thaw season like we are now. Unfortunately, we don't yet have a long enough record to determine normals. We kind of look for more like incremental differences week to week or month to month, and compare individual dates in the archive to capture, what layers are drying or wetting and that kind of thing. So going to the next slide, we'll see a current picture of what it looks like today. So the grayed out levels, the discs and the chips that are gray are ones that are still frozen, or measuring frozen temperatures. So we try not to display that, or they try not to display that to give kind of some inaccurate or misleading information. But we're starting to see thawing through the southwestern quadrant of the state, and so we can get a good handle again at the start of the growing season where we are. All right, the next slide shows another view of soil moisture by individual stations, and this is a really neat way to see how soils respond to precipitation events. So at the top is Redfield, which is in the north central part of the state, let's say. And this is for the month of August, the 1st to the 31st of last year. You can see at the thick bars from the orange, yellow, green, that's given our volumetric soil moisture at each of those sensor levels. And as you go day by day, the purple bar is a precipitation event. That was about a little over 3/4 of an inch of rain. And you could see how it wet the soils, infiltrated into the soils at least about 4 to 8 inches. And then it dried out. And then you can see where the smaller events really don't have any response in soil moisture when you look at the 20th, 21st, 22nd, around that time of August. Until you get to later in the month where you see 2 larger events of about 3/4 of an inch to an inch plus. So it's a really neat way to kind of get a handle on how soils are responding, and if rain events are actually infiltrating into the soil and how deep they're going. Similar on the bottom picture is a station in the northeast corner of the state, showing very similar things, even under some wetter conditions. So we'll go to the next slide there. Just showing a couple webcams from our new webcams around the state, just that we can get kind of visual and start to see green up. So this is actually February 8th of this year. So we're looking at essentially a snow drought, right? There should be a little bit of snow out there anyway. This out in western South Dakota. You know, we can start to see, I looked at this camera also yesterday, and we're starting to see some green up, you know, some of those grasses start to warm up, but this kind of gives us a pasture or grazing or grass, you know, natural environment view. Going to the next one, we can also look at cropland. This is in the southeastern part of the state at one of the South Dakota State University research farms near Beersford, South Dakota. So we can use these cameras to look at different landscapes. Certainly the webcams, they were intended for, you know, kind of quality controlling their data and their snow depth and that kind of thing. But it helps us to understand, is vegetation responding to soil moisture deficits or not, or excess, either way. So a couple more things I want to share quickly. I know we're running out of time. Frost depth, I've mentioned this. We use this a lot. Looking at soil temperature helps us to understand the ability of soils to take in moisture, if our soils are thawed or not. And this is showing the very lowest layer that we're measuring frost temperature, 32 degrees or colder. All right, the next one is showing thaw depth, looking at top to bottom. How thawed is it from the top to bottom? And this is from about a week ago. Today we've been colder lately, so we don't have thaw depth to show, but showing from top down, how deep are the soils thawed out? And so between the two of these, this could tell us a lot about this transition season in the spring, especially if we have snow on the ground. If that snow will be able to melt and infiltrate in the soils, or if it's just going to run off of those frozen soils, and help us to kind of replenish our soil moisture if we needed it. So temperature, soil temperature tells us a lot in combination with soil moisture, and our ability to take in rain events or use that water. So next one, again, just look at temperature again, where we're starting to see, this is currently on the far right, all those layers of soil are right under 32 degrees. So we're ready to thaw out in a hurry for the spring. We will skip this one, and we'll just go to the summary in the interest of time. So just a summary here, we use all the data for soil moisture, including the models, remotely sensed and in situ data. They all have a place for us, and soil temperature provides us a lot of extra useful information, especially in our northern climate in these transition seasons like spring and fall. We're trying to better understand our soil response to both precipitation events and snowmelt season. This year we had very little snow, if any. So we didn't get to test that a whole lot this year, but something we're looking forward to. And the Mesonet, really we have some excellent tools, but we do have a wish list, including improving our data visualization. You know, getting more of the differences between time, like say a month, a week, whatever, to help inform the drought monitor. Going beyond that volumetric water content, as Richard said, going towards something like plant available water and other indicators is where we like to go. And we have soil samples, so they are doing soil characterization with USDA, and so eventually we will calibrate the soil moisture measurement to the soil type, which would be even just a step bigger, a step higher, for us to better understand our soils here in South Dakota. So I think we've come a really long way in the last decade since I've been here, but we have a couple more steps to go, and I think the future is bright for us. I do have my contact information on the last slide if you'd like to share that. But thank you for your time.